We are now live.
And we're live. Hello, friends and colleagues. Welcome to Space Club XV, episode 5. Traditionally the best of the episodes. For those of you who are uninitiated, this is an extended voyage of something we used to do all the time back in our campus days, our university days, our younger days, where myself and Phil mostly, but Tanya certainly when she was around as well, would get together at the grad club, and Phil would provide an update to myself and other graduate students and other colleagues and faculty members on what was going on in planetary science. And, for better or worse, all of us have moved on to have grown-up jobs outside of the academic world. And one of the things that comes with that is not being able to keep up with planetary science news as much because we don't have either Phil every Thursday to meet with, or we just don't have time to be reading and studying all the time because of those grown-up jobs. So, we thought that we would use the magic of the internet and its tubes of information that can go all over the world to carry on in an extended voyage in which you're all welcomed. I know we have friends and colleagues joining, but anyone is welcome, of course. And I myself use this quite often for my course as well, to provide the students some information on ongoing missions. So enough of that. My name's Danny Bednar, a PhD from the Department of Geography at Western University, where I am now an assistant professor, where I teach space exploration. And my Monday to Friday is with the Canadian Space Agency. And that's how I pay the bills. But today, here I am as a professor, I suppose. To my up or down, I'm not sure, is Tanya. So Tanya, how about you introduce yourself? And given the time of year, what's your favorite Christmas song?
Oh, the truth on the spot, I wasn't prepared for this. I'm Tanya Harrison. I did my PhD at Western at the same time as Danny in geology with a specialization in planetary science and exploration. So my PhD is in Mars. And my favorite Christmas song, I really like, there's a sea shanty I've been listening to lately by The Longest Johns. And I can't remember what it's called, but it's their only Christmas song. So if you're into sea shanties, look up The Longest Johns. It's a very cool Christmas song.
It's like Yellow Submarine, like that kind of sea shanty?
Yellow Submarine is not.
No?
That's not a sea shanty.
What's a sea shanty?
No. You don't know what a sea shanty is?
A bunch of guys singing together in a pub, sailing. Sounds like Yellow Submarine.
On a boat.
Oh.
It's a work song.
Does
it give you some rhythm to when you're hauling the ropes on an old sail, something like that?
Yeah, fair enough. I feel like you could row to Yellow Submarine or really anything.
I know why Danny doesn't know this. I know why Danny doesn't know this because you're from Manitoba, right? So you're landlocked.
He's a landlubber.
Well, significant lakes. Well, okay, so thank you for introducing yourself, Tanya. Phil, same question. Who are you? And what is your favorite Christmas song?
Oh, dear. All right. Well, so I'm Phil Stuck, now retired professor from the Department of Geography and the Planetary Science Group at Western. And I am trying to think what my favorite Christmas song actually would be, because I'm going to say Frosty the Snowman.
Oh, that's a good one. All right.
It will be different if you ask me next week.
Okay. That's fair. Next week we won't be doing this. I'll ask you next month.
Oh, okay.
This week is a bit of a special show. I mean, usually we dig into the week or the month that was, and we will be doing that, but we're really going to be focusing on a really monumental event over the last week in regards to planetary science, and that is China's Chang'e 5 mission, and really giving you a recap of the Chang'e program as a whole. Something that maybe here in the West gets a little bit under the radar, but is really a phenomenal space exploration program. We'll also, of course, mention yesterday's events with Japan dropping an asteroid on Australia. One way to look at it. Though, of course, we have a sample return from an asteroid thanks to the Japanese Hayabusa 2 program. So as always, questions and comments in the chat. There's a little bit of delay for us on our side. I'm trying to monitor as well on YouTube, but I know we have viewers on Facebook and Twitter as well. So our viewers are spread out all over. The comments get captured and sent to us through this program, but there is a little bit of delay as they make their way through the tubes. So before we get started, my interest, of course, is in history. So in lieu of the normal rundown of the missions around the solar system, and because we're focusing this week on a current mission, I thought we would still inject some history and a little bit of a runaround of the solar system, but this way more historical. And we're going to kick off with a little bit of this date in history for space. So we're going to go all the way back to December 7th, 903, the 10th century. And this is to celebrate what would be the birthday of Abd al-Rahman al-Sufi, or more commonly known in the West as, well, I've lost it, al-Sufi, Azophi, A-Z-O-P-H-I. There is a lunar crater named Azophi, A-Z-O-P-H-I, a minor planet as well. And al-Sufi published in 964 the Book of Fixed Stars as part of the Golden Age in Persian science and astronomy. Himself and other famed Persian astronomers like al-Biruni, they were working with a lot of Greek and Roman models of the universe and really, for short, making them better. He worked largely with Ptolemy's models, and noteworthy for this gentleman, he probably has the earliest known description and illustration of what he called a little cloud, which turned out to be the Andromeda galaxy. So our nearby neighbor in galaxy terms, which is actually on a collision course with us as we speak. So in another 4 billion years, we'll be combining with the Andromeda galaxy. So I thought I'd give a shout out to al-Sufi. He also died in 986 in Shiraz, Iran. Tanya, does Shiraz, Iran ring any bells?
No, but I'm guessing it has something to do with Mars because you're asking me. Oh God, I feel so bad now. We know a guy from this place.
Yes, we do. I'll give you a break. That was the chapter I worked on. Yes. If you do pick up For All Humankind, available at local independent booksellers near you, don't buy it on Amazon. Well, you can, I suppose. You will hear a wonderful story about a gentleman from Shiraz, Iran, and where he was on July 20th, 1969.
Did something important happen on that day?
July 20th, 1969?
Yeah. I guess I have to read the book and find out, right?
Yeah, that's right. So let's jump to December 7th, 1905. Again, this day. Now, this is not an image from 1905, surely. Phil, do you know what this is?
It's Arakoth.
That is correct. So what, now, this is an image made up with data from New Horizons, which is obviously a probe which flew past this object about a year ago, January 1st, 2019. This is roughly what our eyeballs would see, a little bit exaggerated for purposes. But where is this object?
Right, it's way out beyond Neptune, and in fact beyond Pluto. The spacecraft passed by Pluto and gave us a great view of that planet or object, or whatever we want to call it. And 3 years later, it took that long to get here. It arrived at this little object and took pictures of it. Yeah.
And if so this object has a neighborhood?
The Kuiper Belt. That's
right. So December 7th, 1905 is the birthday of one Gerard Kuiper, a Dutch astronomer. Actually, if you read his Wikipedia article, which I did last night out of curiosity, it's also described as a selenographer, which I will now be calling Phil, and some of my friends. Selenographer would be?
A person who maps the moon.
That's right. So Gerard Kuiper is one of the gentlemen who hypothesized about this thing. And he wasn't the only one, but this is early in the 20th century. We're still in the days of telescopes and drawing based on what you see through the viewfinder. And it was hypothesized that beyond the ice giants, Neptune and Uranus, there should be some stuff. Kuiper was not the only one, but he was certainly prominent among the people who suspected. This was not confirmed for a long time, into the late 1980s. A bunch of observations out of MIT confirmed this, essentially tracking some objects that made sense with objects that would be this far away, this small, and going about the sun. The Kuiper belt is huge. So if you look at this image at this scale, our little planetary neighborhood is not resolvable. That green circle is the orbit of Saturn, as you can see. So our inner solar system, us, Mars, Venus, isn't really even visible at this scale. And that orange circle, not the funky yellow one, but the orange one, is Neptune. And that's kind of the outer reaches of the outer solar system, so to speak. But that's really certainly what we discovered over the last 50 years or so. The solar system is a lot bigger than we thought. Or perhaps it's not fair to call the outer solar system with Neptune and Uranus the outer solar system. There's a much more bigger outer solar system, and it starts probably with the Kuiper belt. And the thick part of the Kuiper belt, where New Horizons is now, is about 50 astronomical units away. So what does that mean? An astronomical unit is the distance between the Earth and the Sun, roughly 150 million kilometers. Neptune is 4.5 billion kilometers from the Sun. And New Horizons now is about 5 billion kilometers from the Sun. And this Kuiper belt goes on potentially for 1,000 astronomical units. Very sparse, not a dense area, but it's just a bunch of rocks and ice out in the outer solar system going on for a very long distance. But it was hypothesized to exist as a identifiable feature, certainly that thicker part, in the early 20th century by, among others, Gerard Kuiper, whose birthday it would be today. December 7th, 1972, 48 years ago, we have, pretty obvious here, Apollo 17 was launched. This would be the last of the Apollo missions. It went to Taurus Littrow. If you're interested in more about Apollo 17, you can watch actually the first virtual episode of Space Club, where we talked about the other Apollo missions, 11, but the others. And this mission had Gene Cernan, Harrison Schmitt, Don Evans. We've talked about this at length, but definitely just a shout out to 48 years ago today, Apollo 17. So, continuing on a little historical journey, we have Cecilia Payne-Gaposchkin, born not on this day, May 10th, 1990, but passed away December 7th, 1979. This young woman, and truly a young woman when she came to notoriety and should have been respect and fame, proposed in her 1925 doctoral thesis the absurd idea that stars were made out of hydrogen and helium. This did not align with existing scientific hypothesis at the time, which, among other ideas, was that the sun and the Earth should have similar composition, and ergo that the sun was some sort of active planetary body or former planetary body, certainly not entirely of hydrogen and helium. As we can imagine, in the notoriously progressive era of the 1920s, this young woman was ignored, not taken seriously. Of course, we do know now that that the sun is made up mostly of helium and hydrogen, essentially entirely for all intents and purposes. And thankfully, Cecilia did go on to become a professor at Harvard, chaired the Department of Astronomy there, and supervised, among other people, Frank Drake, and lived a very full life to the age of 79, passing away on this day 41 years ago. So that's a little bit more history let's jump now to,
So,
yeah, great.
Danny, what was it that made her come to this hypothesis that stars were made out of hydrogen?
Yeah, it was, I think it was amongst early interpretations of, I think this is when the idea of the protoplanetary disk is starting to take kind of form as a concept. And we're getting this idea that, I guess, aligned with, you're asking me an astronomy question, which is phenomenal. That
I'm asking you a history question.
Yes, I suppose. Long story short, the general growing notion at the time about the abundance of hydrogen was a growing theory at the time, and I think she made the leap between, if that's the most abundant element, and we look at how our solar system settled down, she, in a roundabout way, then came to the conclusion that I can't give you any more detail on, that at the center of our solar system should be this abundance. Yeah, sorry, moving on. So December 7th, 1995, again, I have something that's certainly not from 1995. There's some clues definitely in the bottom right. Phil, do you know whose writing this might be?
I think that this is Galileo's writing.
That is correct. Man, you should
recognize the handwriting.
I feel like you saw the 4 moons in the bottom right, but
kind of a giveaway.
or you just know that on this day, the Galileo probe arrived at Jupiter, and the Galileo probe was an incredible mission. I'll jump right to it. That orbited Jupiter, and thankfully took images of the moons, the Galilean moons, Io, Callista, Europa, and Ganymede, and with each one of those moons found a bunch of really, really cool stuff. It orbited Jupiter for about 8 years, had a mostly successful mission, a bit of an issue with one of the antennas. Found all sorts
of a bit of an issue. More than a bit of an issue, it was catastrophic, really.
Well, it worked for 8 years, Phil.
1% of the bits that should have come to Earth from Galileo, probably because of that. But they were very carefully chosen bits, so they told us quite a lot.
Okay, well, you're up to me. I'm not optimistic enough about these missions. But yes, a catastrophic failure then with one of its high gain antennas, which wouldn't unfurl, I think. But told us all sorts of stuff about these moons. Europa probably has a subsurface ocean, which is an ongoing hypothesis that's almost certainly true. Volcanic activity on Io. Ganymede has its own magnetic field. All sorts of stuff confirmed, like its planetary cousin Cassini. Much later, it would carry out a depth dive into Jupiter. Well, Cassini did a depth dive into Saturn when it ran out of fuel. But it was also the first thing we launched into, well, we threw into Jupiter, which was cool. I'm always fascinated by the first thing humans hit other stuff with. And yeah, the Galileo mission, I don't know, Phil, anything off the top of your head about this catastrophic failure of a mission?
I think, wasn't this
incredible that they managed to actually get what they did out of it? Which moon do you think that is in that picture?
Oh,
tricky.
I know, only because I have the note in front of me. I'd be pretty impressed if you knew.
It's Amalthea.
Oh, geez. Well, color me impressed. Yeah, it is.
It's a rhetorical question.
Oh, yes. You would never ask a question you don't know the answer to.
I think, wasn't Galileo also the only interplanetary mission that was deployed from the space shuttle?
Yes, I believe that's. No, Magellan as well.
Oh, I forgot about Magellan. Yeah.
But yes, it was launched from STS-34 in 1989, or Space Transport System 34, as we named the shuttle missions for weird reasons. Yeah, it was launched from the shuttle. So the shuttle took it up to low Earth orbit near this, well, at that time, no space station. Mir would have been there, but I don't know if it would have docked with it in 89. Yeah, from low Earth orbit, Galileo went about its own way, separating from the space shuttle. So it didn't launch from a rocket. Well, it launched from 2 small rockets, I suppose. Yes, that is the the successful failure, as we like to say in space, that is Galileo. Some fancy images of Europa, but we'll move on. Okay, almost done here with our history lesson because we got to get to Chang'e. But in December 6th, so yesterday, one of the many instances in which we found water on Mars, Tanya.
Many, many. So this crater here, this is actually a crater called Penticton. So maybe Canadians will recognize that as a town in British Columbia that has been affected by a very large landslide in the past. They took this name and ported it to Mars for this crater full of landslides. The image on the left here, Danny, you didn't put in the annotated version with dates.
I left them off. It's 1999 and it's 2004.
Okay, I can remember the before and after dates of this one versus
Mars.
Naruko, the other one.
They call me Danny of Mars.
So back in 1999, Malin, who built and operated a bunch of the cameras that are either were or currently are at Mars, started looking at these features called gullies to see if they could look for any changes in them. And the thought that there would be changes seemed like a long shot. But over the course of almost a decade with Mars Global Surveyor and repeat imaging of these gullies, they actually found 2 instances where they had an image of an area where you didn't see any gully activity, like nothing had happened. Yeah, so there you go. And then come back a few years later, and then suddenly you have this bright deposit left behind that wasn't there before. And so the idea was that these deposits had formed by flowing water in some fashion, because it's kind of hard to see in these images, but if you zoom in on the channels that these features are in, they have a lot of characteristics that are highly suggestive of formation involving some amount of water. So probably like a debris flow, which is basically like a muddy slurry of water and sediment flowing down the hill. Why this stuff is light toned, we never really found out, because we looked to see if maybe it was formed out of some kind of salt. Didn't find any signature of salts, doesn't have a signature of ice, so it's a little bit mysterious there. But it could be that they're covered by dust, and so we're just getting the signature of the dust on top. But this was my entire thesis at Western, was looking at every gully on Mars and mapping them out to figure out where they were. And before coming to Western, I actually worked at Malin in operations for some of these cameras, where my job there was also mapping out all these gullies, looking to see if we could find any more of them that changed. And at that point, I found 8 more with Mars Reconnaissance Orbiter, in addition to the 2 that we had found with Mars Global Surveyor. And at this point now, between MGS and MRO, they found, I think now with the HiRISE camera, 40-something active gullies across the northern and southern hemispheres. And so it's pretty cool. There's something going on that's causing these little landslides to form. There's a huge debate in the community now as to whether it's water or some kind of like frost lubricated flow or carbon dioxide gas lubricated flow. If you want to hear the entire saga of all of these theories and why all of them are wrong except for water, you can read my PhD thesis.
Oh my God. No, just write a book or something.
Oh God, another one?
I'm waiting until they make the movie.
Is this center swath? I should have looked it up. Is that HiRISE?
No, that's actually a colorized Mars Global Surveyor image.
Okay. Wow, 90s camera. Looks good.
It's pretty sweet.
Honorable mention, we don't have time, but December 7th, 2015, Phil?
Right, so this is Akatsuki, the Japanese spacecraft currently orbiting Venus.
I don't know why I do any research. Yeah, so just before we get going, most famous instance of Christmas in space exploration overlapping. I can only think 2.
Apollo 8?
Apollo 8, yeah.
Apollo 8. That's right. So Apollo 8 would have orbited on December 24th, 1968. But there is another pretty good one. Unfortunately, it didn't land on the specific day, but here we have an image taken shortly after, January 14th. But the thing that took this kind of did something very special on Christmas Day, 2004. You see some digging into my physical geography, some dendritic things, Tanya. So where could this be if we're seeing kind of streams and stuff?
This is Titan, isn't it?
Yeah.
Huygens?
That's right. So Huygens released on 2004 from Cassini on Christmas Day. It would land a couple weeks later on January 14th, 2005, and of course become the first lander in the outer solar system. So Christmas Day 2004, I'm sure Phil was anxiously on his dial-up modem down updates to this mission. But yeah, really, really cool that this was a Christmas thing. Actually, the year before, Phil, you had also been watching for some space news on Christmas Day, but it turned out to be quite tragic. Do you remember what that was? 2003 Christmas. And I think you did some detective work later on to find this thing.
Okay, I'm drawing a blank. You'll have to remind me.
No Darwins were hurt in this crash.
Oh, it was. Oh, yes, of course. The Beagle. Beagle 2.
Yeah.
Right.
So,
can't figure out. There you go. Yeah.
Yeah.
Beagle.
December 25th, 2003.
Tried to land on Mars. Yeah.
Tried to land on Mars.
That's right.
Try.
Yeah. So now we have MRO high-rise images of the Beagle spacecraft sitting on the ground, and it looks as if it did actually land successfully and begin to deploy its solar panels, but failed before it completed the job. If the images are being interpreted correctly now.
That's really cool and very sad.
Yeah. Okay, last but not least, this day in history, well, yesterday, we have this phenomenal sample return from the solar system, one of very few. So, Phil, what do we know so far about our little pieces of Ryugu that we've collected?
Well, of course, we don't know anything about what's inside that container just yet, but it was quite an amazing mission, 6-year-long mission from Japan, that the Hayabusa 2 spacecraft that flew out to an asteroid called Ryugu. And it actually collected 2 different samples. It touched down first and collected something right from the surface of the asteroid. And then quite a few months later, it performed a different kind of sampling. The first thing it did was to release a heavy sort of inert mass of metal with a little rocket on it. It released that, and then the spacecraft ducked around behind the asteroid, and that mass was smashed into the asteroid. The little rockets fired to smash it into the asteroid, where it dug a crater and threw up some subsurface material around the crater, a little bit of ejecta. Then the spacecraft went back and sampled that subsurface material in the ejecta of this little artificial crater. So there should be 2 samples there, one from the surface and one from sort of slightly under the surface.
Awesome. Well, yeah, space clubs to come. We'll be talking about everything that happens with the. There'll be a curation process, of course, over the next year, but in the future there'll be samples in scientific laboratories where they belong. All right. Well, on to the main show.
Okay. So. Yeah. Okay, so what I'm going to do is just look at the Chang'e 4 and Chang'e 5 missions. We'll have to go through this rather quickly there, but but we'll do that. They were preceded by Chang'e 1 and Chang'e 2, which were 2 orbiter missions, and they successfully mapped the moon. And then Chang'e 3 landed with a rover. The rover only operated for a couple of months before it encountered a problem. But Chang'e 4, which we'll look at in more detail now, has been operating for 2 years on the surface of the moon. And it was actually the first thing that ever landed on the far side of the moon. And if you're going to land on the far side of the moon, you have to have a relay satellite. So yeah,
rocket.
They launched 2 years ago. They landed on the far side on the 3rd of January in 2019. Now they've been operating for 23 months. That's 24 lunar days, because a lunar day is slightly shorter than a month. And right now, they're just about waking up from the 24th night. This is the relay satellite. A little bit of detail about it, but let's pass over this, move to the next slide. This is the landing site. It's a crater called von Karman on the far side of the moon, and there's a picture of the lander and the rover, and the arrow shows where they are inside that crater. Now that's a nice smooth floored crater, and it's smooth because this ancient crater was filled in with lava flows probably about 3 billion years ago or so. But they haven't landed on lava flows. They've landed on ejecta, stuff thrown out of a nearby crater. So you've got the old crater, lava flows on its floor, and then more ejecta thrown out on top of that from a nearby crater. And they've landed on that, and they're examining that right now. So let's just move on quickly. Here's a map of the moon that shows the different places where China has touched the moon now. We can see Chang'e 1 and a spacecraft called Longjiang 2, which was a little spacecraft flying with that relay satellite, but which went into orbit around the moon. The relay satellite isn't orbiting the moon, it's orbiting one of the Lagrangian points on the far side of the moon. But Longjiang 2 did orbit the moon, and then it crashed at the end of its mission. So we've had two impacts there. And then Chang'e 3 on the left-hand side at the top there, Chang'e 4 on the right-hand side at the bottom, that's on the far side of the moon, and Chang'e 5 just last week up on the left-hand side again. So 5 places that China has touched the moon right now.
That's a familiar spot for Chang'e 5 to a lot of people.
Yeah, well, so we'll see where that site is. So the Chang'e 4 had its little rover called U22. It's been driving around. We can see here sort of some of the pictures that it's taken, including its tracks. And the ones in the middle show where the infrared instrument is analyzing rocks. There's an infrared spectrometer strapped to the front of the rover. And if you want to point it, you have to turn the rover. The thing can't point itself. So you sort of turn the rover and move around a little bit until that red spot is on the target you're interested in, and then you take your measurement. Let's move on there. Move on to the next slide. Here we go. So there's a picture of the rover coming off the ramp on the lander and driving off onto the far side of the moon. You can see the rim of that big crater, von Karman crater, is forming the horizon there. And keep on going. Yeah, then it turned around and looked at the lander. So there's the lander. It's got a big long aerial extending upwards and 2 horizontally that are not quite so easy to see there, although you can see their shadows. They're part of a radio astronomy experiment that's performed in conjunction with the relay satellite. So they're not only doing geology on the moon, they're also doing some radio astronomy. Let's move on there. Yes, and here's an LRO image taken about 18 months ago showing the lander on the right and the rover itself on the left. Now, just looking at that, of course, you can't really tell that that little dark spot on the left is the rover, except that on pictures taken earlier, it wasn't there. And actually, the LRO people just released a very nice kind of composite showing the rover in about 10 different positions as it's gone along its traverse. That's a nice little thing.
Yeah.
Phil, we've got a question from Cass on where the best data source is to follow the Chang'e missions.
Right. Okay. Yeah. Congratulations on the new job there, Cass. I would say the easiest way to keep track of what Chang'e 4 is doing is to follow the threads relating to that rover on a couple of online forums where other people are doing the job of collecting that information for you. Unmannedspaceflight.com and NASAspaceflight.com are 2 major online forums which each have threads relating to this mission and to many others. China also puts out what they call a drive diary after every month of Chang'e 4 operations. There have been 21 so far because they started a little bit late. But they tell us a little bit about what's happening every month and include some good pictures usually. There are sources, but I would go to those forums first. unmannedspaceflight.com and nasaspaceflight.com, and you can keep up through them. Okay, let's move on here. This just shows a kind of early stage in the path of the rover, the red line there. It comes off the lander and then goes around and images the lander from 2 or 3 different positions, and then sets off on its path. And as it's going along, it's using several instruments. One is the infrared spectrometer. Oh, let's look at the next picture and we'll see some. So there's a picture of the rover. The spectrometer is on its front. It's on the front left there. Little red circle, VNIS. And it's looking down at a spot on the ground in front of it. So there you can see what they call the exploration area there. It's actually looking at there. And it also takes a little picture showing what it's looking at. Up at the top there, it was looking at its own tracks. There's that instrument. And also this shows that there are a couple of antennae sticking out the back of the rover, which are for the Lunar Penetrating Radar. So let's go to the next slide. And there you can see the tracks and these 2 antennae. And there's another antenna right underneath the rover, which operates at a different wavelength. And between them, they can study the subsurface. So these are sending radio signals downwards, and we get reflections from them, which show us where different layers of material are down below. And if we go to the next slide, we'll see the result of that.
So those circles it's periodically looking at a feature of interest, and it spins to look at it.
It's turning around, so it will stop and then turn to point in a particular direction, and then turn again to drive on. So that's what's making those markings. Yeah. So this is an example. There's a citation down below it of the path of the rover for the first couple of months. And the results of that sampling down below, looking through the surface material to buried rocks, and basically it's getting reflections off rocks. So if there are lots of rocks, you get lots of reflections, and if there aren't very many, you get very little reflection. And by looking at the resulting data set, you can map out the layers beneath it, and they're layers of different kinds of impact ejecta. So you might have a regolith building up over, say, 100 million years, and then suddenly a big layer of ejecta with lots of boulders in it thrown across the surface. And then on top of that, it builds up another layer of more finely ground regolith over another long period. So that's what we're seeing there.
So I've noticed this are question marks like a common denotion in geological maps? I was talking to a friend who's doing work on Pluto, and she also had like layers and then question mark. And like, is this just, I guess there's nothing else you could really put.
Well, yes, that's right. We use the question mark to say, what's that? We don't know what it is.
Yeah, I guess, yeah.
That's where you just put "there be dragons."
That's what they used to do, right?
Well, it's interesting that you should mention that. I have to throw in an aside here. I have only ever seen that on one map. And I've looked at a lot of very old maps, but I've only ever seen that on one map. And it was a map by the asteroid scientist Mike Gaffey of the asteroid 4 Vesta. And he put that on that map, and it's the only place I've ever seen it. I know people always say, oh, yeah, that's what it would be like. But, old maps would show that. But I've never seen it on an old map.
Interesting.
There are old maps that have pictures of monsters and things on them.
Yes.
But they didn't say, here be dragons.
It must be in a movie.
What's the most interesting thing you've seen on a map like that?
What, one of these ancient maps? Well, there's a very interesting old map from about the early 1600s of the the east coast of Canada, showing all sorts of things, including monsters in the sea and cannibals on shore eating each other and all sorts of things like that, most of which was conjectural, to say the least, I would say.
Interesting. Old maps. Well, yeah, I'm curious about the dragons. We'll have to continue thinking about that.
Okay, now onwards. All right, and so there's one other instrument which was provided by Sweden which analyzes atoms, neutral atoms, in other words, not electrically charged atoms that have been scattered off the surface by the solar wind. And most of what's detected is hydrogen. But anyway, there's a potential to analyze things on the surface there. So that experiment is going on every day as well. Okay, move on, because we've got to get through these. Right, so this is one of the places where they stopped to examine a rock target. They stopped at the end of day 2 and photographed the area around them, that's on the left, and saw some rocks. And so the next day they drove up to the foreground rock and analyzed that. The first rock that they'd analyzed, almost everything that they get to analyze with the infrared spectrometer is soil, and they've got lots of soil measurements along the way. But every now and then they find a rock and they get a measurement like this from it. So that's part of that. And this is actually them trying to get that spot actually on the rock. And it takes some doing because the instrument is fixed on the front of the rover. So you drive towards the rock, but you haven't gone quite far enough. So you have to go a bit further, and you're not pointing quite right. So you have to shift a little bit to get it on. But that's what they're doing. And doing all that stuff takes time. So on a day when they spend a lot of time trying to get a spot on a rock, they don't travel very far. Okay, let's move on here. And this just shows a map of exactly that area. They called the rock Lucky Encounter, one of the few named features, and they believe that it's ejecta from this crater called Finsen, which is outside of von Karman, and has thrown ejecta all across the surface here. Okay, let's move on there. One of the things they're really trying to do with this infrared spectrometer is to get very detailed information about the surface composition, but you have to do a lot of calibration to get that right. So this is one of their attempts to calibrate it. They drove to this point, and then they spun the rover around and took a series of different spectra at different angles relative to the incoming illumination. By doing that, they're trying to figure out how the signal that they detect is altered by the illumination angle. So this was one of their attempts to calibrate it. That was done on day 4. And again, because they're doing all that, they didn't travel very far. Okay, let's move on again. And so here's a map going up to the 7th day. And I mark out where they spent the night. And you can see that some nights are pretty close together. The 4th night to the 5th night, they haven't done very much. They've only gone a short distance, about 9 or 10 meters. That's a 50-meter grid on there. The reason is that they spent a lot of time doing that photometry experiment. And we've had that on some other occasions. Okay, let's move on there. On day 8, they found a little crater, and they spent all of the lunar day 9 examining it. So again, they didn't go very far, but they moved around trying to get a proper view of this. What they're looking at was impact glass inside this little crater, and trying to get that instrument, the infrared spectrometer spot right on the impact glass was quite tricky, and they made several attempts to get it. But they did eventually. Okay, and this is just their attempts to maneuver around that spot. The crater's in the lower left there, and they're trying to maneuver around to get a good view of it. Okay, let's move on. Here's another photometry experiment on day 10. This time they took lots of pictures, lots of spectra at the same place, first in the morning and then in the afternoon. They had to move the spot in the afternoon so that the spacecraft shadow wasn't on it. Basically they're calibrating again, this time looking at one spot as the sun angle changes, rather than lots of different positions with essentially the same sun angle, which is what they did before with the other calibration. So they're doing a lot of very careful work here. Let's move on there. Day 12, they decided they were going to drive up to this crater, and there would have been good targets for the spectrometer with lots of rocks around it, but it was too difficult to get to, so move on again. Next slide. And nearby they found this rock, so then they did an analysis of this rock as well. They think this is ejecta from a different crater, but I haven't seen a detailed analysis of that yet. There's a funny little lump on that, yeah, which you can see in the mosaic at top left as well. Probably a clast in a breccia. I think that's an impact breccia, and that spot is a clast or a lump inside the rock. Okay, let's move on. And then they decided where they were going to drive after that. They decided they wanted to head up to the top center area here. This looks a little bit redder. So the spacecraft had landed right down in the lower right corner. The white line shows where it had driven in the first 12 or so lunar days. And now they've moved quite a bit further on than that. They decided they were going to head to that red area, which they think represents some of the basalt material from the actual floor of von Karman crater before it was covered with ejecta. So now they're mapping the ejecta, analyzing the ejecta. Up there, they can look at the surface under the ejecta. So that's what they're trying to do. But it may be several years before they get there because they don't travel very far in a day. Typically only 25 to 30 meters a day. And they've got to go more than a kilometer, so it's going to take quite a bit of time. They could go more, but only if they didn't stop and measure things along the way. So leaping ahead to day 23, just a month ago, they wanted to get to that 30 centimeter rock, but as they approached it, they decided that it was too difficult to get to, so they abandoned that goal, but they analyzed one of the little rocks in the foreground there. And just in the last month or so, they've backed off that position and started to move on again towards their distant target. And this is the map sort of showing where they are roughly right now, with me estimating the position where they are right now. They're probably not that far ahead, actually. I think they're a little bit further to the right than I've showed it there. But they are going pretty slowly. And I want to just very quickly compare this with the only other remote-controlled rovers that have ever operated on the moon.
Glorious Lunacods.
The Soviet missions called Lunacods, yeah, that's right. And they drove much longer distances. Lunacod 1 drove about 10 kilometers in 11 months, and Lunacod 2 drove about 35 kilometers in 5 months. They were driven a lot faster, but they didn't do anything like the amount of science along the way. The science return from the was
precision contact science instruments, though, right? Like,
no, they didn't. That's right. So they didn't do as much science along the way. They just drove longer distances. But I've seen people kind of critical of this Chinese mission because it's not going very far. But they're doing a lot of science along the way. Okay, let's move on to Chang'e 5 now. Make sure that we get to cover this since it's only just happened and it's a very exciting mission. So it launched on the 14th of November this year, landed on the 1st of December. This shows the landing site. Now, this is a Clementine false color image. And the colors just represent different surface compositions. Just looking at it, you can't tell what it is, but you know, from the spectral data, people have some idea. The blue area is young lava flows. I think they're quite rich in titanium. So young lava flows, and the yellow stuff is older lava flows, and the slightly redder material is the highland material with a very different composition. And the thing that's most interesting to people is the young lava flows, because they were never sampled by Apollo. We know that there are some areas with quite young lava flows, but we never got any samples of them. So these will be the first, and when they arrive back on Earth in a week or so, they'll be the first, and they'll be scientifically of enormous value, showing the later stages of lunar volcanism. So the white arrow shows where they landed there.
We talked about Apollo 17 and earlier. They kind of thought they were going to get some really young material, right? They
did, but they didn't. They thought it would be younger, but that was a mistake. The reason they thought it would be younger was that they landed in a valley which had a landslide coming down off the side of the valley and out onto the valley floor. And then there was a little crater with a dark halo around it on the landslide deposit. If that had been a volcanic a little volcanic eruption site, then it had to be after the landslide. So that was how it was interpreted before they got there. But what was actually found was basically older material from underneath the landslide that had been dug up by a little impact crater. So they didn't find the young volcanics they expected there. Here we will have something very interesting, and these will be very highly sought after samples when they get back to Earth. Okay, so
NASA tweeted out that they hoped that China would share the samples with the scientific community. Do you know if NASA has ever shared the Apollo samples with China before, or not because of the political tensions there?
Well, those political tensions are relatively recent. I'd say the last 10 or 12 years. What NASA did quite early on when it had the Apollo samples was to distribute samples around the world to many, well, in fact, every nation on Earth got some sample, a little bit, a kind of symbolic amount. Other than that, then you have to apply to get samples. But China does have a little sample from Apollo, but the political tensions now mean that it would be impossible for them to actually get anything officially like that. But there is no prohibition against Chinese scientists working on research that is not federally funded. The prohibition is against federal US funding, as I understand it. So people who are funded federally, which includes, of course, a lot of scientists and includes US Geological Survey scientists, for instance, and that sort of thing, they can't work with China. But people who are funded in other ways, including European scientists and so on, have no problem doing that. So I guess the upshot is that people will be able to get these samples. Even Americans will be able to join international teams that have the samples and will be able to work on them. But there can be no direct interaction between China and American scientists who are federally funded. So yeah, it'll be a little bit complicated, but some people will get the samples. And China will be making all this available. They will be doing that. They make all their data available to people, and they will make the samples available. So anyway, this is the landscape in front of the lander. We don't have a full 360-degree panorama from the lander, just a sort of a half panorama here. That hill on the horizon showed up on the map that we just saw. It was just kind of below the landing site on the previous image. And that shows what it looks like. And they put up a flag, so that shows the flag there. Nice view of that. Not a territorial claim, of course, just like the Apollo flags were not territorial claims, but it shows who was there. Let's just move on here. They collected samples with two mechanisms. One is a drill on the upper left, and one was a scoop on the lower right. They actually had two different scoops operating in different ways. They will have collected about 2 kilograms of sample, which is quite a lot, and it should be a really good collection of samples. And then that stuff had to be lifted off the surface. Here we have an illustration of that, lifting off the surface there. And the two arms that we can see there, on the left is the arm that delivered the drill sample up into the sample container on top of the little ascent vehicle there. On the right is the scoop that had scooped up samples. Or actually, I've probably got that the wrong way around there, but one of it, that's what the two things are anyway. One is for the drill and one is for the scoop. And they collectively, they delivered their samples to the top of that spacecraft. And then it lifted off. It met up with an orbiter in orbit very successfully just a couple of days ago. And now the samples will be returning to us in a bit more than a week.
Wow, your lecture timing is impressive. That's many years sharing.
I had to go a little bit faster there, Danny. You stole some of my time.
Yes, mine is.
Danny, you said it was going to take you 15 minutes max. It took you half an hour.
Yeah, that is correct. I was off. Yeah, that's awesome. Yeah, the only thing I was reading about that you didn't mention was the sampling process was about 19 hours of work.
Yeah.
For the ground scientists, which was, yeah, I mean, I guess that's nerve-wracking, right? One of those arms seizes, or one of the, something doesn't go right, and it's kind of cool though. There's contingency.
The good thing is that there were two different methods of collecting a sample. If we look back into the 1970s, when the Soviet Union also collected 3 separate samples with robotic spacecraft, they only had a drill, and 2 of those drills didn't work very well. 2 out of the 3. So they got very, very small samples from a couple of those missions, and a relatively decent one from a third. But it was tricky. So here they've had 2 separate and redundant methods of collecting samples, and they both worked apparently. So we should have a really good sample.
I'm gonna have to check this, but Luna 17, I think it was the first one, and then 23 and 24 for samples.
Okay. So Luna 16 was the first one. Luna 7 delivered the rover Lunar 1.
Oh,
right?
That's why. Okay.
And then Luna 20 collected a sample from the highlands near Chrysium Basin. And then so Luna 16, Luna 20, and then Lunas 23 and 24. 23 failed at the point of landing, and 24 succeeded.
Okay, so 23 and 24, right? And 17 was COD. That's fair. Okay.
And the architecture for Chang'e 5 in terms of like the ascent vehicle, docking in orbit, coming back to Earth, that shares a lot of similarities with the Apollo missions, right? Just at kind of a smaller scale since you're not involving humans.
Well, yeah, that's right. It does. And it's a lot more complicated than the method that the Soviets chose. Their little spacecraft came back directly from the lunar surface to Earth, but because of the way they did that, they were very limited in the area they could sample. This Chang'e system could sample anywhere on the moon effectively, so it's much more flexible.
So is Mike Collins waiting in orbit for this thing?
He should be. That's right. Yeah, I expect he was watching with interest.
Yeah. All right. Well, that's going to wrap another episode. This episode, I think, was kind of proposed by someone who was watching last time. I think I can't remember where we got it, but yeah. If you have an idea for the next episode, I know
think you're right.
People, yeah, and I think a few people have mentioned Venera, but it was cool to do Chang'e because it's happening right now. So yeah, any suggestions that come our way in the next week or two, for sure. We won't see you again until the new year. We'll all be getting back to getting back to our jobs and then to the holidays. So any parting words, Tanya?
I would say as a suggestion for a future episode, inspired by the Galileo chat, I'd love to chat about Galileo and Juno and like what did we learn with the first mission? How did that tie into what we know about Jupiter now?
I think that's a great idea.
But more generically, I hope everybody has a good and safe holiday season.
Yeah. Likewise.
Phil? Yeah, likewise. Okay. Yep. Same here. So yes, take care of yourselves, stay safe, be kind to one another, and we will see you in another month or so with Space Club XV episode 6. So thanks, everyone.
Okay. Goodbye, everyone.
Thanks. Bye, everyone.